All right, so real quick, I'm going to run through some of the netcat, wireshark, and HTTP lab options for you for the end of day one stuff. So real quick, we'll just sort of replicate what's going on in the netcat tool. So I'm going to open up two terminals. I'm going to open up side by side. I'm going to zoom in so you can see what's going on. All right, so in my left, I'm going to have my left terminal kind of pretend to be the server, and I'm going to have my right terminal kind of pretend to be a client. What we're going to be doing is opening a tunnel, a port, a connection from one client machine to another client machine. And then through that port, you can send information, right? This is how all network traffic stuff kind of happens. It starts with someone opening a port and someone connecting to that port, and then they send bytes back and forth. So I said the left was going to be my server. And so if you follow along the slides, it's really straightforward. You can type the NC command. That stands for netcat. If we hit enter, I'm sorry, if we hit NC TAC H, that'll show us all the stuff we need to do, all our options. Listen mode and port, right? So we're going to listen on a specific port for a connection. By default, it does have this TAC E, and you'll see that kind of come in a lot. And you'll notice it also even says, you know, dangerous. So let's see here. It's clear. NC TAC listen on port 1234. And if I hit enter, you're not going to see anything because right now it's just waiting for someone to connect to it. I'm going to use the right hand. And now this would be on a different computer, ideally, if we were in a lab environment or something. But on your machine, you can kind of replicate this process by doing this. So I can type, first of all, I need to know what is the IP address of that target computer? What is the IP address of my computer? In this instance, I am the target. IP address. I can see that the ETH0 interface is likely going to be, you know, a real IP address on like on a school network or a coffee shop or something like that. So I'm going to see if this works. I'm going to type NC. I want to connect using netcat to this host, this IP address, space on a certain port. The port we said earlier was 1234. That's where we're expecting to be able to talk to someone. 1234. I'm going to hit enter. Nothing appears to have happened. Well, like I said, netcat is just kind of a simple utility to open that wormhole from your machine to their machine. You still have to send something through that wormhole, right? Through that connection. So what am I going to send? I'm just going to type stuff on my keyboard. You'll notice that both of them are just kind of sitting there in limbo, kind of waiting. I'm saying, yeah, we're open, we're established. I'm going to say, this is a test. And as soon as I hit enter, netcat knows you've signaled to me that something has come through that you want to send something through that wormhole. I'm going to receive it and ship it through that network connection, through that TCP connection to the other side. The other side, the server over here, is waiting, and it says, oh, I see something coming through the wormhole. Let me capture it, parse it out, and put it on the screen. That's exactly what you see. What's nice about this is it's kind of a bidirectional tunnel. Once that connection has been established, I can come over here. This is a reply from the server. And if I hit enter, the client is now kind of waiting. It's in like sort of a call and response loop. It doesn't matter who is sending information and receiving information as much. The notion of a server is really more about who is doing more giving of information at this point. So, or the role of a particular computer. So this is the netcat demo. Some other interesting things we can do. I'm going to go ahead and hit Control C because it's not going to do anything. I can't type quit to get it to do anything. Control C is how we just break out of programs. You'll notice that when this side stopped working, this side also stopped working. There's a workaround for that. I'm going to hit the help menu one more time. Keep alive option on socket -K. So what that does is that this will allow me to make sort of a long living server, right? So if once a person connects and disconnects, it's not going to disappear. So I'm going to say LKP netcat listen, but keep it alive on port 1234. Now, if I try to connect again, this is from term 1. Let me see if I can't put this one up here. I'm going to open a third terminal, put him down here in the lower corner. I'm going to connect to that server again. Except notice that it says this, time connection refused. We can't do that. Remember, sockets are kind of one communication only. In order to do that, we'd have to have what they call like a forking server, right? So sounds funny, but what it's going to do is it's going to break off and it's going to just handle a new connection and then hand off. Every time someone connects in, it sort of tells it to pivot to a different port to have that second layer of communication. So this is just kind of like a tunneling thing. So this is a dumb utility that allows you to do really simple socket operations. But in this top window, I can send messages back and forth. But as soon as I exit, oh gosh, that shouldn't have died. Why didn't my K work? Oh, okay. Well, why? Let me try this one more time. -K, a separate thing? I don't know. Oh man. All right. Well, then disregard. I was expecting K to work. I don't know. We have to dig into the man page and figure out why that doesn't work, or dig into the Google more appropriately, because isn't that easier to just find your answer. The other tool I was going to look at was NCAT. NCAT. Oh, why is that not there? Oh no! Stop! Stop it! What time is it? Oh no! Why aren't you doing this? Which NCAT? So I'm searching through the packages to see if it exists. NCAT right here. So I'm going to go ahead and install sudo apt install NCAT. All right. So NCAT is very much like netcat, except they said it was a re-implementation of NCAT. So NCAT, you must specify a host to connect to. This is slightly different. NCAT TAC H. We have a bunch of new stuff, right? So it keeps like a lot of the same like flags, like -L, -P for like listening to a port, but it gives us a couple like little really cheat little things. Like we can build a little chat server. Like before, I could only have one person connected at a time to the server. This time, if I type NCAT tac chat, oops, I don't know why it's that chat. Oh, I'm sorry. -L 1234. So I'm listening on port 1234, and I want it to behave like a chat server. Now, if I use NCAT, NC, I think I can use just any old plain like netcat client. So let's see, 10.0. Let me just try it again. All right, connected as user 5. So anytime someone connects in, I can say, hello, or something like that. Let me connect them again. So connected, already connected as user 5. So I now have 2 people connected. I think I can type just like, this is a message. And those messages get broadcast to all the other people connected to this particular chat server. This is a response. User 5 sends that to there. So it's kind of a fun little like network socket communication. So this kind of pivots into the Wireshark lab. We can go to the start, like the application menu, type Wireshark, and it should prompt us for our password, Callie. And we'll do a couple of different things with Wireshark. We're going to be monitoring the ETH0 interface. And as I send messages back and forth, this is a test. I was hoping that because this is probably traversing the TCP/IP stack, that's probably why that's not going to work. So I think the best way to actually show Wireshark is going to be like monitoring web traffic right now. So I'm just going to leave those open in the background because they won't matter. I'm going to follow along in the Wireshark lab kind of outlined in the slides. And it says visit a website. There's a website listed there, HTTP bin, something or other. Web browser. Oh, already some stuff has started to happen that I really, I guess, wasn't planning on happening, but that's fine. It doesn't matter. I'm going to paste in the website. Actually, no, I'm going to stop. Start it fresh. Clear out the screen. I'm going to have Firefox go to the website I specifically asked it to go to. Now, with any luck, we're going to see a bunch of, traffic coming through. I'm going to hit the stop button. That's all related to the website we're asking for. The website we went to was HTTP bin. And let's see. It looks like my computer initiated a connection to a DNS server right here. See DNS, and it says HTTP bin. So it's making a query. So real quick lay of the land with Wireshark. This is the packet summary. This whole middle section here with all these brightly colored rows and columns of information. This is the packet sequence number. This is the time column. The time column actually is the offset in number of seconds since the packet, like since you press the go button, right? Sources who initiated this instance of communication and destination to this intended recipient. Protocol is whether it's, now this is where it kind of gets confusing. It's not TCP, UDP exclusive. It kind of speaks at all layers of the OSI model. So it can look at Ethernet frames. It can look at 802.11x frames. It can look at HTTP instances of communication. It knows that this bit of this byte sequence is in the context of HTTP. Therefore, it's going to treat it like HTTP. And so you can do some interesting things like that and sort of filter based upon the protocols that are present. When I click on these columns, you can also sort by them. Sometimes that doesn't really make a whole lot of sense though, because right now the packet, like the order in which they're displayed is not the order in which they occurred, like in a timeline of sorts. The only way to really get it back in time is to sort either on the time column or the packet number column. So that being the case, if the lowest numbers are at the top of the thing, as you scroll down, then you're moving forward in time. So it's safe to say that this request happened before this request. And you can look at the time column to understand that this is a smaller number than this. Therefore, it's, it happened in a preceding kind of thing. I can't ask for information I can't get information from a website before I even initiate communication with the website, right? And if I sort on any of their columns, that's what I'm looking at. So this is the packet summary. This is the display filter column. So I can filter out based on these protocols, what they call, there's a whole language and like syntax to these things. I can look at exclusively IP addresses that match this particular field, that match a certain sequence of bytes that are of a certain protocol, a certain packet number, for instance. One very common one is to just filter out like DNS. And if I hit enter, you'll notice the bar went green. Green is good, red is bad. It's that simple. This shows me all things that adhere or sort of match the protocol dissector that is DNS, right? So it says if it encounters a certain sequence of bytes that would be valid DNS request, it's going to end up rendering in this particular display filter. You can use this to sort of trim down kind of quickly, like, oh, okay, what's happening here? I don't want to just look at DNS. I want to maybe look at HTTP. So HTTP is another protocol. I can see that there was a GET request, a response, another GET request, another response. What if I only want to see HTTP dot status? Oops. Oh, is it not status? Is that not one? Or server? These are all the responses from the servers. HTTP dot server, right? My computer, my Kali box is not a server in this instance. So it's not going to be shown in this output except as the destination. If I want to find only a certain IP address, this one's super useful. IP.addr equals, and then so whatever I'm looking for. For instance, I see 54.91.118.50. This will show any packet that is either where the source is either this IP address or the destination IP address. Like, I'm sorry, this IP address is either the source or the destination field. So that's a super useful one. I can look at just UDP. It turns out that this DNS, it lives on top of UDP, right? It's not a connection-oriented protocol most of the time. I look for TCP. So, I mean, the display filters are super powerful. You can build, this is a long bar, it goes all the way across the screen. You can build really complex display filters. This is the little accordion frame. I don't really know exactly what to call it, but it allows you to sort of look at each component of the protocol and sort of tear it apart. We were talking about TCP, and during our Nmap scans, we're going to look at these a little bit more in depth because they kind of have ways of being abused. But looking at the flags, you can see that this is an acknowledgement packet that's being sent back to the client. So let's see about this one here. These are all, I'm just looking at the flags basically. Let's see what else is there. As we crawl further down though, at some point there's going to be additional text, and that's kind of where this hex view at the bottom is kind of interesting as well. These are the raw values as they fly across the wire. If I click on one individual like component within this, you can see where it's kind of getting highlighted within the packet, right? I'm sorry, the raw hex dump. I hit timestamp, I hit sequence, this. You can see these things kind of like changing and jumping around, being highlighted. And as I move around down here, it'll sort of tell you like which portion of the communication you're looking at. So if I look at one that's kind of a server response, you can see that not only is it TCP, but it's HTTP. And then on top of HTTP, there's this line-based text. This is the text of the web page itself. If you look at this, you can see HTML, title, links, so on and so forth. If we look at our web page, view the page source, that's exactly what we got. HTML, title, links. That is the information that was sent across the wire. So that's that. We've already hit the start and stop button. We're going to do a lot more in-depth stuff with Wireshark. If you wanted to learn more about how HTTP works, this is that last lab opportunity. We can go to Try Hack Me, and you can probably explore this evening, learn a little bit about it. And I think this walkthrough might be on YouTube. I'll make sure that it's in the links for you. So you're able to sort of like look at all this, and they kind of give you another breakdown on Wireshark a little bit, or at least an opportunity to look at it a little bit. They talk to you about the response codes. It's important to understand how this stuff works, how the web works. If we're going to do web hacking, if we're going to hack into websites, we need to know how websites operate. So they're going to talk to you about this stuff, and let's see what's in here. There is a machine to start. All right, so I'll make sure that there's a video on like how to connect to the network available to you, kind of on short, like a short introduction. So if we do this, walk through this, get the answers. They're going to tell you how to walk through all that information, and there will be a video for you to watch that'll sort of guide you through in addition to this one. So, all right, I think that's it for right now. We'll talk to you later.